So the last time we talked about how we develop one group diffusion equation to model the distribution of neutron in first infinite slab reactor, finite spherical reactor, and infinite cylindrical reactor. And we develop how the neutron flux will be distributed in all these geometry. The first one that we look at is for the slab reactor, infinite slab reactor, where we get our flux to be equal to A sine B1x. For spherical reactor, we get to the phi is equal to A sine B1 R over R. And for cylindrical, we get to the phi is equal to A J naught B R. The B1 here is something pi over A. This one is equal to pi over R. And we have this one to be 2.405 R and all those things. One thing about this thing is this. You will discover that in all these things, the flux at the center of any geometry always have the maximum. So the first thing we want to look at today, once we know what will be the maximum to the average flux, we already know that definitely the flux will always be maximum at the center. If you look at this point, no, this one is cos, A cos BR. Look at it. And you know that when you plot your cosine graph, it is always symmetry. That is, it looks like this, where this is the center. So because it is always symmetry, the center is always the maximum point. So now we want to look at, suppose we know the flux that is at the center, which will be our maximum flux. We want to know what will be the relation between the maximum flux and the average flux. So for this one, I'm going to work with spherical reactor, because the spherical reactor that we deal with is a finite spherical reactor. While the other, they are infinite slab reactor and infinite cylindrical reactor. But the one that we have to be spherical reactor is a finite spherical reactor. So we use it to determine a value for maximum to average flux. Now, before I start, the value, the maximum to average flux is given. We normally use this thing for it, omega, capital omega. So when you see this one, it means maximum flux to the average flux. That is omega is equal to phi max over what? Phi average. Okay? Now, let's assume or let's consider finite cylindrical spherical reactor. We know that the formula for flux in a spherical reactor is given as phi is equal to P over 4 ER EF R squared sine pi over R pi R over R. This is the formula for complete equation for flux distribution in a spherical reactor. For us to get the maximum flux, we know the maximum flux will occur at what? At the center. That means the maximum will occur at what? At R equal 0, because the maximum will occur at the center. So, if you want to get the maximum flux now, it will be phi max will just be limit this equation at r tends to 0. That is, limit as r tends to 0 of p over 4 er ef r squared sine pi r over r. Let's close it. There's something that we can take out of this thing. So this one will give us p over 4 er ef r squared limit as r tends to 0 sine pi r over r. If you take it like this, if you substitute r equal to 0, it will be indeterminate. So we have to use L'Hospital rule. Using L'Hospital rule, what do? We have to differentiate the numerator and the denominator. At that point, this one will go to 1. This one will go to what? 1, and this one will now be p for the equilibrium energy ef r squared limits as r tends to 0. This one, something will have come here. That's pi over r3. So when we differentiate, this one will have come to cos. So when r equals to 0, the whole thing will be 1. So we now have it to be what? So our phi max will now be p by p over what? 4 er ef r3. This is our maximum flux. Am I right? So now, let's make this one to be, let's just hold it. Let's now look at our average flux. Our average flux will be the total flux divided by volume. Am I right? Average flux will be the total flux of everything divided by the volume. Be something like 1 over v dv. That will be our average flux. But we know that P, the operating power, is equal to what? ER EF phi dv. So from here, I know that my phi dv will be what? P over ER EF. Am I right? So my phi average will now be 1 over V P over ER EF, which is P over ER EF V. So I can now calculate my maximum to average flux now. Because this is my average flux. This is my maximum flux. So this one will now be phi max over phi average, which is now equal to pi p over 4 ER, EF, R3 times, I will change it, ER, EF, V over what? P. So we now have E to be what? Pi over 4. What's the volume? Times 4 over 3. This one see R cube, abi? Yes. 4 over 3 R cube. Am I right? Volume of a sphere, 4 over 3 R cube. Am I right? So this will be 4, we cut to 4, R will cut to R. It will be what? Pi squared over what? 3. So the maximum flux to average the result what? Pi squared over 3. Thank you.